Welcome back. Today we will be talking about Unit 2.4. It is about the graphs. So these are the parent graphs of the basic functions that you should know. Just by looking at it, you should be able to recognize. So the first two, the constant and the identity function, they are talking about a linear function. Because as in the name, linear, it means line. So when the slope is 0, we have a constant function, right? Where slope is 0 on the horizontal line. Now, when the slope is greater than 0, that means we have increasing graph. When slope is less than 0, we have a decreasing graph. And when slope is undefined, that means we have a slope as a number divided by a 0 when calculating the slope. With the linear graphs, how to write the equation of the line, you should also know that y is equal to mx plus b is the slope intercept from, and we have discussed about it in great detail previously. Now, keeping that thing in mind, every x value matches the y value. That is what the basic principle for the identity function, right? F of x is equal to x, or y is equal to x. Whatever is x, that is the same value for y. So this is about the constant and the identity function. Now the next is the absolute value function. So the absolute value function, it is in the form of a V shape. The parent function for the absolute value is f of x is equal to absolute value of x. I can rewrite it in two ways because it is a technically it's a piecewise function. Because when x is greater than or equal to 0, we have positive x, or x is less than 0, we are taking the function as negative x, even though whatever goes inside the absolute value bar will come out positive, but we need to define it as a piecewise function. Now let's talk about the domain. So domain for an absolute value function is all real numbers. That means from negative infinity to infinity. When we talk about the range for the parent function, because if you see the vertex is at 0, 0, that is why the range is the closed at 0 and it goes to infinity. And I already said that the intercept is 0, 0 because for the parent function it is intersecting at 0, 0. Now where the graph is increasing from 0 to infinity, and it is decreasing from negative infinity to 0. I think I wrote it wrong. So increasing at 0, infinity, and decreasing at negative infinity and 0. Now, a few more things about the absolute value function, that it is an even function, right? And it has a symmetry with respect to the y-axis, because you see, it is symmetrical along the y-axis. So with the absolute value function, always remember that it is a piecewise function, because you need this information moving forward in this course and even in calculus. Okay, now this is done. Let's talk about the another one, which is a square root function. So if you look at the parent function, it starts from 0 and it keeps on going to infinity. So the parent, so you should be able to know how to write the parent function and how the graph should look like. So this is my parent function. If you look at the parent function carefully, we can say the domain, it is a set of all non-negative real numbers because it is starting from 0. There can be many transformations with all of these parent functions that we will discuss in Unit 2.5. What is a range? Range, again, it is a set of all negative real numbers, right? Because it is in the first quadrant. What is the intercept? Intercept is 0, 0 because it is starting from 0, 0 only. And the function is increasing. So the function is increasing from 0 to infinity. The function is not decreasing, so we are not talking about decreasing function. So it is 0 and infinity. Now let's talk about another 4 types of functions. Now the first, you should be aware about the quadratic. You have done quadratic in Algebra 1. So it is a basic thing. A quadratic function is also called the squaring function. because it is x to the power of 2. So what is the parent function? Parent function is f of x is equal to x squared. So what are the properties of this? This is a U-shaped graph. Is this even? Yes, the function is even. And when we are talking about the domain is all real numbers because we are on the first quadrant, we are in the second quadrant, and we are just talking about the parent function right now. And range is set of all negative real numbers because the graph is going up. Remember, it is just a parent function. With the transformation, the graph will look like something else and the domain and the range will change. Now, what is the intercept? Intercept is 0, 0. See, on the graph, it is touching the x-axis at 0, 0. And it is symmetric with respect to the y-axis. Now let's define where the function is increasing or decreasing. So decreasing means going down, increasing means going up. So let's write it down. So the function is increasing from 0 to infinity. It is going up, and decreasing from infinity to negative infinity to 0. Right? And if we talk about the relative maximum, relative min, this graph has a relative min. It has a valley at 0, 0. And you should also know the basic standard equation of a quadratic, which is ax squared plus bx plus c is equal to 0. And there is a way to calculate the axis of symmetry. Axis of symmetry is nothing but the x value of the intercept. So ax squared plus bx plus c is equal to 0. This is your standard equation for the quadratic. And axis of symmetry is negative b over 2a, and you will get the x value of the intercept. So this is the basic structure of quadratic function, or another way, it is called a squaring function. Now, the another thing is the cubic function. As the name implies, cubic function, that means to the power of 3. So as you can see in the graph, it is kind of squiggle, right? It is a squiggly line, or is the S-shaped graph. So f of x is equal to x cubed. That is the parent function. Again, we are talking about only the parent function. And it has a power of 3, that, and we are saying that the function is odd function. Let's talk about the domain. So domain is all real numbers because the graph is in the third quadrant and in the first quadrant as well. Range for this graph will be all real numbers again. And the graph has the intercept at 0, 0 because at 0, 0, it is changing, right? It is changing the quadrant. Now let's talk about where is it? It is increasing. So it is increasing everywhere. So negative infinity to infinity, that is your increasing interval. Because it is changing from third quadrant to the first quadrant and the squiggle, we can say it is symmetric to the origin. So have a good understanding, and you should be able to map these functions in your mind, even with the closed eyes. Oh, how the function should look like if the function is this, if it is a cubic function or it's a quadratic function. Now this is very, very important, the reciprocal function, or this is also called a rational function as well. Because till now you have not learned about the rational function in Algebra 1, so just understand it really carefully. Few things and it will be okay. So if you look at the parent function, f of x is equal to 1 over x. So if x is 0, when x is 0, it will be undefined, right? That is why the graph is not touching 0, x at 0. So the domain, it has, the function is cut into two pieces, or it is two graphs comprises this function. So the domain is negative infinity to 0 and 0 to infinity. Now 0 is not included because it is not touching the 0. So the range is negative infinity to 0 and 0 to infinity again. Again, the 0 is not included, and with infinity we don't use the closed parentheses. We don't use the closed dots. We just always use the open dots. Now, a few more things about it. there is no intercept because the graph is not touching the x-axis. It is not even touching the y-axis as well, because these are something called asymptote. We name it as asymptote. I will define the asymptote for you, but let's talk about the decreasing. So it is decreasing at negative infinity to 0, and it is increased at 0 to infinity as well. It is decreasing. The function is not increasing at all. With respect to symmetric, this function is symmetric with respect to the origin. If you see, they are just mirroring each other, first quadrant and the third quadrant, right? So basically, graph breaks in two parts. So you can write it down, graphs break in two. So if you have all of the characteristics of these functions ready in your notebook or wherever you want to write, then it is easier for you to recall. Now, I was talking about the asymptote, right? So if x is 0, the function will be undefined, because when 0 is entered, that is undefined. That means it is not touching the axis. And that is called something called asymptote. So get yourself familiarized with the word asymptote. So asymptote is a line. The function is approaching and it acts as a boundary. So the function will get closer and closer to this boundary, but it will never touch this particular boundary. And that is the definition, the simple definition of asymptote. It will never touch. So these are called the asymptote. So whenever I discussed this in earlier video as well, that whenever we are talking about something is undefined, we are talking in terms of asymptotes. Now, how the asymptotes are working in this case, let's understand it a little bit more in detail. So if I say, so when x is equal to 0, for f of x is equal to 1 over x, then it is undefined. You need to write this thing down. Function is undefined. Now, what is going on if we are coming from the right-hand side or we are coming from the left-hand side? So when we are approaching x, or x is getting closer to 0 from the left-hand side, right? So from the left-hand side of the number line, when the function is approaching to the x, we are not reaching x because we cannot touch x. Then y approaches to negative infinity. You can see in the third quadrant, the graph is going downwards. Now, what will happen if x gets closer to 0 from the right-hand side? Then how the y is behaving? So if you look at the first quadrant, y is increasing. As the x is getting closer to 0, y is increasing, and that is in the first quadrant. So that's how you can define the behavior of the function. Right? So if you look at the graph, it is reaching infinity in the first quadrant, and in the third quadrant, y is reaching negative infinity. So very important. So take it a little bit more seriously. This is the first new thing that you have learned. Now, the another thing is the greatest integer function. So if you look at the function, it looks like a staircase, right? Stepping up. And the stepping up is quite uniform. All right. So if you look at the stepping up, it is at every integer. We are not talking about any decimal or something. So this is also called the piecewise function or the step function. Some books have might say piecewise function, some might say step function or staircase function as well, or greatest integer function. So you might also see something called a floor or ceiling. So these are two different ways you can calculate it, but we will just focus on one thing. So this is how you will write the parent function, and pay more attention on how the brackets are used, right? These are not the normal brackets. So this is called the greatest integer function, and it says it should be less than or equal to greatest integer less than or equal to x. So pay more attention on integers. What are integers? So let's take example. So if we have -1, so what is the smallest less than or equal to x, the integer that is smaller or equal to x on the number line? So -1 is an integer, so we will just say -1 because it is less than equal to. Equal to is -1. Let's understand how the decimal will work. So now we have the example f as -0.5. Now it is a decimal, right? So it is not an integer. So we want something that is less than or equal to -0.5. What could be less than -0.5? That is -1. So they are simple, but be careful about the integers. So have a good understanding what are integers. And we have discussed this in the previous videos, in the first initial videos. So domain, as you can see, all real numbers, and the set and the range is also set of all integers. Only integers. We are not talking about all real numbers, because real numbers will include the fractions and everything. We are just focused on the integers. So what is the intercept? Intercept is, we have y-intercept at 0, 0. And x-intercept is if you can look at the graph, the x-intercept, it is a closed circle. So we will use the bracket for the closed circle. So it will be 0, 1, because 0 is included, but 1 is not included, because for 1, we have the open circle. So look at the graph on the left-hand side. So at 0, it is closed, and at 1, it is open. So this is the basic structure of the greatest integer and all the parent function that you should be quite familiar with. Before we end this video, try this question on your own. And remember, when we are talking about the greatest integer, we are talking about integers only. So this is here, and be careful about how you write the greatest integer. And I will see you in the next video, and bye-bye.